Hey guys, welcome to this yet another exciting live session from Edureka on data science. Today's session is going to be all about predicting the future. Interesting, isn't it? And we are going to do that using the time series algorithm. All right. So without wasting any more time, let's move on to the agenda to see what all we'll be covering today. So we'll start off our session by first discussing why do we need time series analysis. All right, and then we're going to move on to what is time series analysis exactly, and then we're going to see when not to use time series, right? So what are the cases in which you should not use time series analysis? After that, we are going to discuss a few of the components that time series algorithm has, and towards the end, we'll be doing a demo. All right, so I hope this agenda is clear to you guys. And before moving ahead, guys, I want to know, are you guys clear with the idea of maths? Right? I don't want to scare you with scary maths today, but I just want to get an idea at to what extent I have to explain the concepts today. So can you please confirm me in the comment box with your reply? So I repeat, are you guys familiar with few of the concepts of maths such as what is mean, what is variance, what is covariance, right? And how many of you are familiar with the data science background? All right, so I can see that Avinash is saying he's clear. So is Ajay, Manish, Avinash. All right, so Avinash says absolutely. I like your confidence, Avinash. All right, so let's move ahead and start off with our session. So the first topic is why do we need time series analysis? So for those of you who are not acquainted with data science, there are quite a few algorithms in data science which can predict values. All right, but why do we need one more algorithm called the time series algorithm to predict values? So let's see with that. So if you would have noticed in other algorithms such as the linear regression or logistic regression, there were two variables, right? One was a dependent variable and one was the independent variable. So you used to predict the dependent variable based on the values of the independent variable. For example, a particular value of x, you used to give a particular value of x and you used to see what will be the value of y. But in time series analysis, the scene is that you will be given only one variable and you have to predict that one variable. Now, imagine if you just have one variable, how will you predict it? Right? And the only thing which will be given in the data set is in accordance with the time that is there, right? So for example, if I own a company, I own a car company, I own a car company, and I say that last month I sold around 23 cars. This month I sold 24 cars. What is the sales that I'll achieve in the next month? All right. So in these cases, you would have noticed that the only variable that I have is the sales part, right? I don't know what is so I don't know what is the other variable that I have to depend on. The only thing that is there is time, right? So I have to predict for the next month. So same as the scene here, you use time series analysis when you have only one variable and you have the time as a second variable that you will be predicting the value from. All right. Now, this is why you use time series analysis. Now, let's now understand what is time series analysis exactly. All right. So time series is a series of data points indexed in a time order. All right. So it's a series in which you have indexed the points according to a time order. Now you use a time series algorithm to create a model, right? And once you have created that model, you use that model to predict values, right? You predict the future values, whatever future values you have, right? Whatever depends on your use case. So this is what is time series analysis is all about. You create a model, you give it the inputs of the past, and you predict the future values. All right. Now, moving ahead, guys, now this is where you use time series analysis. So I told you, whenever there is a time component, you use the time series analysis. But when do we not use time series analysis? So we don't use time series analysis whenever the values are constant. All right. So for example, I say that my company sold 23 cars in the past month, 23 cars in this month. Tell me what is going to be what is the sales that is going to be in the next month. So right. So in this case, my number of cars is same for the previous month and this month as well, right? So there is no need of any analysis or there is no point of putting an analysis over here because it's kind of obvious. And if it is not obvious, maybe there is something that is going to be there next month. Maybe there's going to be a discount next month or something like that. But all of those parameters, if you cannot include in your analysis, there's no point in putting that analysis, right? And specifically time series analysis, because it is all dependent on time. Having said that, so like I said, if values are constant, you cannot use time series analysis. Similarly, you cannot use time series analysis if you have if your value is can be represented using a function. For example, the sin x function, right? So if you have the x value, you can get that value by putting it in the function. Now you can apply time series analysis on this as well, but there is no point because you could have got that value by putting it in the function itself. Right, so like the sin x value or the cos x value or any other formula for that matter, right? So there is no point in doing time series analysis if you have a formula before that. Okay, now this is the scene when you should not use time series analysis. But what are the cases in which you cannot use time series analysis? In the sense, you cannot do time series analysis if the data is like that. So there's a concept called stationary. So if your data is not stationary or your data series is not stationary, you cannot apply time series analysis on that. All right. So what is stationary? So for the series to be stationary, there are three conditions. So the mean should be constant according to the time. All right. The variance should be equal at different time intervals from the mean. So now for those of you, so mean is basically the average, right? For those of you who don't know what variance is, it is basically the distance from the mean. So each point distance from the mean should be equal at equal intervals of time, and that is what variance is all about. That is how far each number is from the mean. All right, so this is what variance is all about. Then we have the covariance, so that should be also equal. So if these three conditions are met, then only we can say that my series is stationary, and then I can apply the time series analysis. All right, so let me give you an example. So guys, this is my R console, right? Now, if I want to find the mean, so let me first show you the data that I have, right? So this is the graph that my data is representing. So basically, I'll be doing my time series analysis on air passengers today. All right. So this is the graph that air passengers data has right now. And if you want to see the data set, this is how the data set looks. Right. So we have data from 1949 to 1960 for each and every month. And we have to predict for the next 10 years what will be the sales of the tickets. We'll do that today. So, okay. So for now, we are concerned with the mean. What is mean? So mean is basically the average of the points. You'll be calculating the average of these 2 points, and you'll be pointing. You'll put a dot here. Similarly, you'll put a dot here, and you'll parse a line through it. So let me show you how that line will actually look like. Now this is the mean, guys. This is the mean that I've plotted. So as you can see, the mean is changing according to the time frame. So if I talk about the years, my mean is changing, right? It is not constant. For example, in 1950, the mean is increasing. From 1950 to 1952, my means value has increased, right? So this means value should not be increasing. It should be constant. So this we have to look at. And then let's talk about variance. So variance is, like I said, the distance of each point should be same from the means. For example, this particular point over here, or let me get a bigger wave. So this particular point and this mean, if this is the distance, then this particular point and this mean should also be the same. But that is not the case right now. So we have to transform our data so that our variance becomes equal. All right, so that is what we are going to do right now. So if my variance and my mean and my covariance, they become equal, my data series becomes stationary, and hence I can apply time series analysis on that. All right, so this is this is what you should be clear till now. If you are clear till now, the journey ahead is a cakewalk, guys. There's nothing tough to what is going to be there in time series analysis. All right, so we've discussed what cases we should not apply time series analysis to, and which cases there's no point in applying time series analysis. Now let's move ahead and understand the components of time series. All right, so when you talk about the components of time series, guys, there are basically three components. You have the general trend, then there is seasonal, and there are irregular fluctuations. So let's discuss these three components in detail. So the first thing is the general trend. So a general trend is basically how are your values going? Are they increasing or are they decreasing? All right, so let me give you an example by showing a graph. So let me go back to my R console and let me give you a trend. All right. So guys, this is the trend that my values are going through. That is, my values are increasing every year. And that is how the trend is going. Now my trend can be either upwards or it can point downwards. All right. And it's a component of time series. Now you can see that in the data set as well, that my values are increasing and hence the trend is going upward. All right. So pretty simple. This is what general trend is all about. And then we have seasonal. So what is seasonal data? Or what is a seasonal component? So a seasonal component can be understood something like this. So you have an airline company, right? Now you would have noticed that at every festival, there is going to be a peak in the number of commuters that are going to take your airline. For example, near Christmas, a lot of people will be going home and hence there'll be a spike in your in the number of people who will be traveling through your airline. And hence you would have also noticed that whenever you try to book your tickets in the peak times, that is during Diwali or during Christmas, that the fares are quite high. And they are high because the airlines, they have already speculated that at this particular time, my number of passengers would be more, and hence and it is imperative for you to go home, right? And it doesn't matter how much cost they are asking you, and hence that is the time that the airline makes the maximum profit, right? So this is the seasonal part that I'm talking about. So in a year, how many peaks do you see? So if there are 2 festivals in a year, you will see peaks twice in a year. If there are 3 festivals in a year, I'm talking about the airlines perspective, guys. So if there are 3 festivals in a year, you'll see 3 times that the peak is going to be there. So this is called the seasonal component of your time series analysis. And then comes the irregular fluctuations. That is the random component that is going to be there in time series analysis. So what is the regular component? The regular component is basically irregular component is basically something like say in November you have fog and hence a lot of flights were cancelled, right? And the number of commuters hence goes down. But it is not going to be the same case in say the next year. Maybe next year the fog is not going to be there. All right, so it is not something that is repeating every year, right? It is something that is not in our hand, right? It is something that are uncontrolled circumstances. So when we talk about these circumstances, these are called the irregular fluctuations that you have in your time series analysis. All right, so guys, these are the 3 components that we are going to deal with when we are going to analyze today. All right, so let's start with the analysis now. So here it is, guys. So first of all, you will be importing your data set, right? So this command does that. So you'll be passing data and then air passengers. So we've imported the data set now. Now, if you want to know what class our dataset belongs to, for example, our dataset belongs to the time series class. So we can check that using this particular command. And you can see that it shows TS, which basically means time series. And then what is the start of the time series? It can be checked from here. End of the time series, it can be checked from here. So it says 1949, first month, that is January, 1960, last month, that is December. All right, frequency. So frequency basically tells you the intervals that you have. So there are 12 months and hence you have 12 intervals. Summary of air passengers, that basically gives you all that regular thing, that is the minimum cost, the maximum value, the median value and everything. All right, and like I said, so this particular command will give you the mean, right? It gives you a mean of your time series analysis. So that is it, guys. Now let's go on and understand this particular part. This is the most important part, guys. So it gives you a box plot. All right, so let me zoom it out for you. So guys, this is the box plot, and in this you can analyze in which particular month I was experiencing the maximum uh, traffic, or the maximum passengers were traveling. So for my data of 11 years, I can see that every year the number of people who are going more, or people who are traveling more, is in the month of August. So 7 means August. So in the month of August, and in the month of July and the month of August, my number of passengers who are traveling are more. All right. So I can, this is the seasonality part that I was talking about. So with this graph you can check the seasonality, and similarly you can check, one second. Yeah, so similarly you can check the trend of your data. Right? So if I execute this particular line, it will show you this trend. Right? Now I have to convert this particular function, or this particular series, to stationary first. So as of now it is not stationary, as you can see. Right? The mean is also increasing, the variance is also not equal, like I showed you. Right? So moving ahead, guys, now let's make it stationary. So for dealing with the variance part, first we'll be applying the log function. So if we apply the log function, what basically it does is, it'll make the variance equal. Let me show you how. So if I pass a mean line now from here, the variance is going to be equal. So as you can see, this distance and this distance, and this distance, they're almost equal. Let me zoom it out for you. Right? They're all equal now. So if I pass a mean line from here, each point is going to have the same distance at each interval of time. All right. So this can be done using the log function. All right. Now similarly, now the only hurdle that I have right now is that the mean is still changing according to time. Right. So I want the mean to stay constant according to time, so that my series becomes stationary. So the way to do that is differentiating it. So I'll type in diff, which is the command for differentiating, and I'll plot the graph now. So as you can see, the graph is now, the mean is now constant according to time. So if I plot the mean line from here, it is not going to change with time. As the same time, my variance is also going to be the same. All right, and this is what I wanted. So my series is now stationary, and I can now apply the model on it, the time series analysis model on it. Now when it comes to modeling, guys, there are quite a few models that you can apply to do the time series analysis. You have the ARIMA model, you have the Holt-Winters model, etc. Today we are going to cover the ARIMA model. So let's discuss what ARIMA is. Right? So let me first, so ARIMA is basically an acronym. Let me tell you what the full form is. Right? So let me go here and type in ARIMA for you. So it is AR, capital I, and then MA. Right? So AR stands for autoregressive. All right? MA stands for moving average, and I stands for integration. All right, so AR, what is autoregression? Autoregression is when you're seeing the past values to predict your own value. That is called autoregression. Moving average, there's a formula for moving average using which you take different intervals and you calculate the average. All right, you can go ahead and search what moving average is, or you can also check out one of our videos in the data science which talks about this particular thing. All right, so I'm skipping this part right now because then our session is not going to end. So for those of you who don't understand what moving average is, it is okay, guys, because what we want to know is the inference. We have to derive the values from the graph. All right, and that is what we are going to do. So for your understanding, AR means auto regression, MA means moving average, and I is integration. So with these three, we have values. All right, we have some values associated. So with AR, I have the value called P. With I have the value called D, and with MA, I have the value called Q. So whenever I'm applying the ARIMA model, I have to go ahead and include these three values as well. And these values I have to get from the graph that I'm going to show right now. It is called the autocorrelation function graph. Right? Using that graph, we will determine what is the value of P, what is the value of Q, and what is the value of D. All right, so let me show you how you can do that. So first, let us see the autocorrelation function when we are not applying anything to our series, when we have not transformed our series to stationary. So this is the graph. As you can see, the values are exceeding the blue line. All right, so our aim is to keep it under the blue line and invert. So so let me show you how. So if I apply the differentiation and the logarithmic function to my data series and call the ACF function, which will plot the ACF graph, I will get a graph like this. All right, so when I get a graph like this, now with ACF I calculate the value of Q. As you can see in the comment, I will calculate the value of Q. Q is the coefficient for MA. All right, that is the moving average. So how I can calculate Q is like this. So I'll see the first line, right? It is crossing the blue line, so I'll skip this line. I'll see the second line, I'll skip this line again. So the first line which gets inverted, all right? So for example, this is the 0th line, this is the first line, and this is the second line. So the line which gets inverted, just before that, the line which is there, we have to take that value. So for example, this is the 0th line, this is the first line, this is the second line. Right, so we'll be taking the first line or the 1 value. So my value of Q will become 1. Now there is a lot of maths behind this particular graph, guys, but since I'm not going into the formulas, this is the easiest way to understand how you can calculate the Q value and the P value. Alright, so like I said, I'll repeat it again. This is the 0th line, this is the first line, and the first line which gets inverted, I will take that particular line and I will take the number which is precise to the previous line for that. For example, the 0th line, the first line, and the second line gets inverted, hence I'll take the first line and hence the first value. Alright, so the value of Q becomes 1. Now let's check out the same method will be applied in the partial autocorrelation function graph as well, and from that graph I will get the P value. Alright, now as you can see, this is my 0th line. Alright, and immediately after my 0th line, my first line is becoming inverted. So hence my value of P becomes 1. Alright, so the value of P becomes 0 because this is the 0th line, right? So my value of P is 0, my value of Q is 1, and my value of D. So D is basically the differentiation that you do in your function. So for example, my time series algorithm, I did differentiation and hence I got the mean to be equal to or the mean not changing, mean constant to my timeline, right? So the value, now you can do differentiation multiple number of times. So I have done differentiation only once and hence my value of D will be 1. If you do differentiation twice, my value of D will be 2. If I do differentiation thrice, my value of D will be 3. So you do that until and unless your mean becomes equal or your mean becomes constant. Alright, and hence that will be the value of your D. So in my case, the value of D becomes 1. So my value of P is 0, my value of D is 1, and my value of Q is again 1. So I'll be using that in my ARIMA model. So here comes my model now. So I'll be applying all of that. So this is the PDQ values that I was talking about. So when you pass this particular function, right, you will be specifying the PDQ values. So this is your P value, your D value, and your Q value. So these parameters change according to your data set. Whatever data set you're taking, these parameters will change, and you have to get these values from the graph and hence put them here. Alright, so in my case, like I said, PDQ are 0, 1, 1, so I put them there according to that. And you would have noticed that I'm not adding the differentiation part here. That is because I've already specified the ARIMA model that differentiates this particular data set once. Had I specified 0 over here, in that case I would have mentioned that differentiate this thing as well. Alright, so I'm not putting that because I've already specified 1 over here. Alright, so let me pass this line. So this creates my model, and now I'll be predicting values for the next 10 years. Alright, so you'll be specifying 10 over here. If I want to predict for the next 15 years, I'll be specifying 15 over here. So it'll pass it into the predict function. This is the model that we have created, and this is the time frame that we want our model to predict to. So we want it for 10 years, and hence I've specified 10 years. And then once I have predicted that, now remember guys, this is the most important part, that your values are in logarithmic form, right? So to convert them into the decimal form, you have to use the e value. So the e value is 2.718. So for seeing the values, I have to pass this particular line, which will basically say, it says e to the power of the value of the predicted value. Alright, so let us see the predicted values, and here it is. Alright, so I had my data set till 1960, if you guys saw, and my data set and my analysis has now given me the values till 1970. So it says in the year 1970, in September, I will have these many passengers who will be traveling by air. Similarly, in 1961, for the value of January, these many customers will be going through air. Alright, so this is what my model predicted. Now, I can also test this model, and before that, let me plot this as well. So let me show you how it looks in the graph. So I had values till here, remember? And these dotted lines is what I have predicted for the coming years to be there. Now, in this model, you have taken care of the seasonality factor. You have also taken care of the irregularity factor, and have also taken care of the trend. All these three factors combined, you have predicted the values for the future. And this is how your future looks like. Till 1970, this is going to be your peak value. Alright? Okay, now we have created the model. Let's test this model. So what we are going to do now is, we are going to take a data set till 1959, and then we are going to predict the value of 1960, and then we are going to validate that value of 1960 from the already existing value that we have in our data set. Alright, so let us do that. So first, let me recreate my model till 1959. Alright, so here it is. Let me show you the data set that I'll be working on now. It is till 1959. So my data set does not have the 1960 value now. Right, now I'll be creating the model out of this particular data set. Alright, done. Now I'll be predicting the values and changing the values to decimal form. Done. Now let me show you the value for 1960. So these are the values. So now you would have noticed that they are in decimal because of the calculation part, but we can round them off, right? So let me first get the 1960 values alone so that it becomes easier for us to understand, right? And then let me round them off with this particular command. Okay, so if I see, yeah, so now I can see it pretty clear that my value for January of 1960 it's 419, for February it's 399, for March it's 466, and so on. Alright, let me go on to the original value now. So if I compare it with the original value, one second. So this is my original value, guys. So originally in 1960 January, 417 people flew, and according to my model, 419 people flew, which is pretty close. Same is the case with February. Originally 391 people flew, and I predicted 399 people will fly. So as you can see, guys, it's strikingly amazing that you can actually predict almost close to values for the future, right? And if you would now, you would be thinking, is this really used? Is time series analysis really used? So let me tell you, it is actually used and very widely used in the industry. For example, say I have a call center company. Say I run an e-commerce company, and my customers call me on a daily basis, and I have to adjust the shift of the people, right? So say there are around 100 people now, and uh, I have total of 100 people which can handle the maximum traffic. All right. So I'll see at what particular time. So say for example at 4 p.m. I get around 20 customer calls, but at 8 p.m. I get around 60 or 70 customer calls. Right. So I can predict that for tomorrow, and I can arrange the shift of people according to that, because my employees will not be working for me for 24 hours, right? So I have to adjust the shift so as to I can match the needs of the customers, and I can predict how many customers will be calling me by time series analysis. And this is the actual use of time series analysis. All right. So, and this is it, guys. We predicted the value for 1960, and we saw the original values, and we came to a conclusion that these values are actually pretty close, and hence our analysis was correct. All right. So this is it, guys. Let me come back to my slide. So guys, thank you for attending today's session. I hope you learned something new today. Now, before ending the session, let me quickly show you the data science offerings that we have. All right. So guys, we offer data science course as well to people. So if you are interested, you can go on to this particular site. My team will be commenting it in the comment section. That is the CLP URL link. So we offer flexible patch timings. That is, we offer timings at night as well, and we offer timings in the morning as well, because we understand you are professionals. You don't have time. You have to work in office as well, and then learning it on your own may become burdened for you, and that's why we have flexible timings. And we have weekend and weekday batches as well. So you can look at the course details over here. You can also go to the course description to see what all we have included in our course, what are the projects that you'll be doing once you have done the course, etc. Right? So this is it. And then we have a blogging section for those of you who want to learn them or learn it on their own. You can always visit our blogging section. You can check out our different blogs that are there in our data science course. And also on YouTube, we have a very big playlist of around 52 videos in which we have tried to explain the basic concepts of data science. So if you are a learner who is keen to learn data science, you can go to our YouTube page and learn all of this. All right. Okay. So guys, with that, thank you for attending today's session. Like I said, I hope you learned something new today. And please also, to be updated on our upcoming live sessions, you have to subscribe to our channel. So you can click on subscribed, and once you click on subscribed, you will have this bell icon, right? Click on this bell icon to get notified for our next live session. All right. So thank you guys, and have a nice day ahead. Goodbye.